So what in the world is the TVM solver, right? It stands for time value money solver. And it's a very powerful app, right? You might not think so, but it's located in finance, right? And I will tell you this, sometimes it's not going to be obvious which one to solve for. You read the question, you're like, I don't know, which one? Start filling in what you know, and the one that's obviously not there is the one that you're supposed to solve for. And then maybe you're gonna get a step closer to what you're actually supposed to do when it comes to answering. Okay. Remember your signs. I will guide you through it. But yes, this is obviously different than what you have because I was doing other stuff, right? I was going through some keys here. But anyways, yesterday we did this first example using the TVM solver, and this one did not have any payments or regular deposits. Watch out for the wording. Is there an indication that you're just putting down one lump sum and leaving it? Is there a situation where you're only making payments? You're starting with zero, you have nothing, but you make regular contributions? Is that the case? Or are you doing a mixture? Are you putting down a big amount and then you put some more every month or every week or every 2 weeks, right? So we're going to kind of see how this changes, right? And we started with a very basic example where you just, you put down $3,000. Why was it negative? Well, the money is leaving you because you're giving it to the bank, right? And you know what they do with the $3,000? They don't put it in the vault. You think they put it in the vault. They lend it to somebody else. They're required to keep some of this money in the vault. By law, I think they're supposed to keep like 10 or 15% like in the vault. You're like, what? What if I want my money back tomorrow? They have 10% of everybody, right? Everybody's money's in the vault. And so if you come and want your $3,000, they have it, right? If every client on the same day at the same time decided to withdraw all their money, they'd be in trouble. They probably would have to somehow come up with the funds after a while, but they would be in trouble. So just a little side note. So anyways, this asks you to find the value of the investment at maturity. That should tell you, right, that we're asking for future value, right? If this doesn't make sense to you, start filling in what you know, and the future value is the only one left, right? So that's what they're asking for there. Next, calculate how much interest you earned using two methods. This is my favorite because it's quite often faster, especially when you have payments involved. However, this formula works every single time, whether n is a whole number or a decimal, right? So that's important to remember. This one works every single time. So if you have a preference, you pick the one, but you should get the same answer, right? Next, you'd like to know how much interest we'll have earned 3 years into the investment. Will be earned. Okay, I actually was right there. Anyways, determine this amount. So now it's in between. It's not quite getting you all the way to the end of the investment. It's just the first 3 years, right? We know way up here that this is actually a 5-year investment, but we're interested to find out, hey, what if it's only 3 years? Where did I put all my highlights? Anyways, I'll use the other ones for now. Right, so you know that it's only 3 years. So we don't just plot in 3 years there. You can't do that, because that would just be the first 3 quarters, right? We go 3 years times 4, right? The 4 quarters, because it's compounded, or the PY. This is PY, by the way. Okay. This number, like whatever time in years is given to you, you have to multiply it by PY so that it jives with whatever is in your N, right? So we're saying, hey, there's 20 compounding periods or payments over the 5-year stretch. Therefore, a 3-year stretch will translate to 12 quarterly payments, right? And that's what we put into this. You cannot use this formula when it's partial, right? When it's only in between somewhere. Okay, so 12 quarterly payments into it, we earn 397.58. Okay, and I put this finding interest within investment, right? It's not the whole, it's just within it. Okay. Next, how much will be in the account, right? How much money will be in the account after 4 years? Not interest, not principal. How much will you have in the account after 4 years? In this case, you need to use this one. Balance, like balance is kind of like how much do I have after a certain amount of time? But again, you can't just put 4 in there. You cannot. This is time in years. Okay, this is time in years. So we will go 4 years times 4 again, and this is PY, right? So we're actually going to say, hey, I want the balance after the 16th payment or calculation of interest. Okay, so that's what goes in here. And balance doesn't need a start and an end. You just give it. I want to know how much I have after the 16th quarterly period, basically. So here's the kicker, guys. Balance is basing its decision on what you have in TVM solver. So for me in particular, I cannot just go ahead and use it. I have to redo what I did at the beginning. So if you did anything between yesterday and today with TVM solver, you need to redo this. Okay, so I'm going to quickly figure this out. Let me just go alpha solve. So now I have what I want to have in here. You need to quit this screen. A lot, even myself, I often want to go straight to balance. Don't do it. I'll show you one time what's going to happen. Okay, so let's say you're there and you go, okay, I'm going to go apps, finance, balance. It's going to insert balance into this. You don't want that. Okay, so let me clear this, put a 4 in there. You quit this screen, then you go apps, finance, and balance here. And we're going to put in 16. And you will notice that when you do a lot of TVM solver questions, you have these functions already on your screen. Just go up and find it, copy it, and just insert whatever number you want in there. And so it's 35.41 and 49 cents. And does this answer make sense? And don't worry about the sign when you're answering. It's only when you're entering it into TVM solver that you need to make sure. And the reason it's negative is because this money is still in the bank, right? You're just accumulating in the bank. That's why it's a negative answer there. So don't be alarmed by it. So this is how much you have after 4 years. And it should make sense because by the end of the 5 years, you will have 3,691. So you're not quite there yet because it's not quite 5 years, right? So if you wanted to find the balance after 3 years, what would you do? 3 times 4, right? 3 years times 4, that would be 12. You run it again, you'd have this much money in your account. After 1 year, sorry, this was 1 year, right? After 1 year, no, sorry, this is 3 years, 3 times 4. After, let's say 2 years, this would just be 8, right? 2 times 8, 2 times 4 is 8, right? So you can see how that will change depending on how many years is being talked about, right? And sometimes PY is monthly, right? So that'll be 12. So just keep an eye on it and you'll be fine. All right. Let's answer F. How much interest would be lost, right, if you got a 3% rate instead? So we way up there, what was our interest rate? We had a 4.17 interest rate, right? So we're gonna say, hey, what if you got 3? What if it dropped? Your bank says, hey, we can't do 417 anymore, it's 3, right? What if you got that instead? So we basically copy everything we have up there. We still deposit 3,000. There are no payments. Future value is what we want to find out. You're like, it's talking interest, Mr. Dirksen. Why future value? That's what I'm talking about. Let's fill in what we know. The compounding is the same. Everything is the same. It's just a lower interest rate. So that would mean that after 5 years, right, this is still 5 times 4, still 20. We're going to make less, correct? The future value will be lower because we got a lower interest rate. They don't pay us as much. So go to your TVM solver. Change the 4.17 to 3. And I'm just going to go to future value right there. I'm going to go alpha and enter to get the new number. And this is my new number, 3483.55. I solved for that, but it doesn't tell me anything about interest. Okay, doesn't tell me interest. So what I'm going to do is I'm going to use this one. I want to find out how much interest I will have earned from the start to the very beginning, end, right? To the very end, which is 20. You can tell already that is 483.55, right? The interest. But so I'm going to quit my screen. I still have the interest up here, right? That function. So I'm just going to go 1 to 20, and that's 483.55. The interest in in B, right? Sum of interest from 1 to 20 was what? Let's just go, it was 691.50, okay? So the difference between that is the loss. Loss of, right, we're just gonna go 691.50 minus 483.55. And I have the answer here somewhere. That's 207.95 would be lost. So you'd lose $200 if the interest rate dropped. Okay. And so this number seems small, but if you have hundreds of thousands of dollars in your savings, which if you save enough, you'll see later, is the case, you'll be losing thousands of dollars by the interest rate dropping 1.17% basically. And remember, we could have done rate of return, all of that. It's coming back. But for now, I just wanted you to familiarize yourself with these functions, okay? With TVM solver in particular. Okay, let's keep going. We're going to do a question, and I tried to put headings on there where it says TVM example involving regular deposits. And I'm going to ask you to take risks. They're very low because if you make a mistake, there's not much to erase, right? So maybe you might be asking, Mr. Dirksen, when can I use TVM solver and when do I use the compound interest formula? Because some examples you can do with using the formula. The answer is, unless I explicitly tell you to use the formula, you can use TVM solver every time. If there's compounding, you can use the TVM solver. If there's no compounding, we're talking simple interest, do not use the TVM solver, right? If it's simple interest, i.e. no compounding periods, you cannot use the TVM solver. This is only for compounding periods, which is most things in the financial world are compounded. So you use this, okay? So let's read this, and then I'm going to ask you to fill this in, okay? Leonard opens a TFSA account, tax-free savings account, and deposits. So there's a deposit made of 10 grand, okay? The interest rate offered by the bank is 2.58%. That's important. And it's compounded monthly. Right there, you should know that CY is 12. It's a bit small, but CY is 12. N is 12, and the formula, right? If you're using the formula, it'll be N, the lowercase n. He wonders how long in years, right? So how long in years will it take to have 15,000 to buy a Subaru Impreza, right? Determine as many of the TVM solver numbers as you can, which one is missing, and then solve for that last value. That's what I want you to do. What does that value represent? Okay. So you need to do this, N, I, PV, and if you forget these, just go to your TVM solver app and copy them. PY, CY. After a while, you're just going to remember that. So I want you to fill in as much as you can here and actually solve for the one that's missing. And I'll see you in a bit, okay? I'll meet you there. You got this. The only thing that I need to remind you of is when we fill in N, it's time and years times what? PY. Okay? Therefore, the number you get here when you solve for it's like as if you multiplied these two to get that, right? So you will have to divide by PY to get that in years in this case. Okay, so let's do that together. You got, I'm going to fill in what I know, 2.58. Present value is negative 10,000. Why negative? Because you're depositing that. There are no indications of regular deposits or payments being made, so that's 0. Future value is what you would like to have, right? 15 grand. It's positive now, right? It's positive because in the future, you're wanting that money back, right? So it's coming back to you, so it's positive. There are no payments, so it's like, that's confusing, right? Well, let's focus on compounding. We know that this is 12. Therefore, this will be the same, right? These two will be the same, so you got them both covered. There must be something in each of them, or else you won't be able to do it. Then that means that this is the only thing I can solve for, and I actually have to enter that because of what follows, right? So I have to catch up with you now. I'm just going to go ahead and do this. Negative 10,000, 0, 15,000, 12, and 12, right? And then I go to N, alpha, enter. And so that is 188.7911. I'm going to go 4 decimals on that one. But that's not time in years. Time in years, you'll have to go N divided by PY. Okay. That's the for sure safe way to do this and to convert anything in years. When you solve for N, you do this. So time would be 188.7911 divided by 12. Because it's saying for this thing to happen, if it's compounded monthly, there will have been 188, almost 199 monthly periods will have gone by for that to happen. Okay, so when you divide that, where is my key here? It's still a ridiculous amount, right? It's still 15.73 years. By the time you get there, your Subaru is an antique, right? it's already old, right? So it's going to take a long time. But however, let's just write that down. That is your final answer right there. That's how long it would take in years. And if it said years and months, then you would just turn the 0.73, right? You'd multiply it by 12 and so on, okay? Can I ask you to do something right now? Most likely you're going to need to know how much interest was earned. This one is actually very easy to figure out, right? It's just 5 grand. There's nothing else that happened. But interest, I'm going to use this formula. Actually, I know why I'm saying this now. You actually cannot use that sum of interest. Remember, when n is not a whole number, you cannot use that one. So not a whole number, so you got to use that n is not a whole number. Okay, we got to use this one. Future value minus present value minus n times payments. There are no payments, correct? That's right. There are no payments, so we just ignore that. For now, you might think some of these things are irrelevant, but I'm building it up for later when there are more moving parts, right? I'm just going to underline this because it's not really what they're asking for here, but I have a feeling it's going to come back later. Actually, it's going to come back later, right? So this is just an aside. Maybe let's block it off, right? So it's just like it's there. I know that I earned 5 grand in interest. I didn't do anything to other than letting it sit there, right? For 15 years, I might add, but it is what it is. After doing the calculation in A, Leonard realizes that it will take way too long, right? Since he gets paid bi-weekly, he sets up an automatic deposit of $50 every 2 weeks. It's very explicit. It's a deposit, like it's an additional amount on a regular basis. Those would be your payments, right? How long in years will it take to save up 15 grand in this case? So let's do this. NIPV PMT. You got to do this every time you use the, sorry, this is PY, sorry, PY, CY. Did I forget one? I forgot future value. Future value. PY, then CY. So when payments are involved, you got to be careful, right? The compounding is still assumed to be the same, okay? Payments per year, in this case, there are payments per year. If it says every 2 weeks, what is that saying? Same thing as bi-weekly, yes, bi-weekly, which means that there will be 26 per year, right? There are 26 bi-weekly periods in a year. You need to know that. So I'm going to insert 26 here. So in this case, they differ, right? PY, CY are different. So it's very important to remember that. Future value, I still want that to be 15 grand. The payment is 50, correct? So that would be halfway right. You're giving that to the bank, right? You're depositing it, so that needs to be negative. Very important. This is where the sign is more important than ever. And we're still depositing the 10 grand at the very beginning. So we have a lump sum that is put down and then additional payments being made. The interest rate we're assuming is going to be the same. And now what's left over here is to solve for n. Right? So go ahead and solve that. So all I'm going to change here is I'm going to go to payment, turn that to negative 50. And you got to watch out, because if you change PY to 26, unfortunately, it will change CY as well. So you just got to make sure you turn that into a 12, right? Because they are different. And then we go all the way to N, and it should be faster, right? Our goal should be achieved a lot faster. And there it is. It's 80.2144. I like to circle the one I solved for or put a dot next to it. Either case is fine, but it doesn't yet answer it fully. Okay. So time in years will be 80.2144 divided by what? PY, right? So it gets a little complicated because these are bi-weekly periods, because that's what your PY is, your payments per year. So this is divided by 26. So you gotta, I write down 4 decimals, I go to my main screen, right? And then just go ahead and do that. That's 3.09 years. 3.09 years. Much better, right? That is the time in years right there. So you sped up the process, right? You made it happen quicker. Question though, which one did you earn more interest? Like actual interest where the bank paid you to get there? This one or this one? Which one paid you more interest overall? Here, you put down 10 grand, you earned 5 grand solely on interest. Like the bank made this grow to that, right? You letting it sit there. In this case, you put in the 10 grand, but you helped it to get to the 15 grand. So it will take you less time, but actually you didn't earn as much interest in this case, right? Because you helped it get to the goal, right? So some observations that need to be made there. Okay, let's go to C. So remember, if you're solving for N, watch out what the question is asking. Is it time in years? Make sure you divide the N by PY. That's important there. Yeah. We would actually plug in this one. That's how many payments happened. Yeah. So C, how much interest was earned in A and B determine the rate of return for each scenario. Okay. You got to be kidding me, Mr. Erickson. That's too much work. So for A, can I just do this all over again? We don't have whole numbers for N. So I'm going to treat them both the same. Okay, so you go like this. And for A, it's just 15,000 minus 10,000 minus 0 because there are no payments. So the interest there is 5 grand. Sorry for repeating too much, but okay. And for B, for this one here, you cannot use the sum of interest because N is not a whole number. So you gotta, it's not gonna be the full picture. It's gonna be close, but not quite. So same thing, future value minus present value minus N times payment. In this case, there are payments, right? So I is future value minus the present value minus 80.2144 times the $50 payments you've been making. And that, I'm going to clean this up a little bit. This subtracted gives you 5,000 minus this times that gives you 4,010 and 72 cents. So the interest is 989 0.28. Right? So we calculated the interest on the first one and the second one using the formulas. Right? Make sure you have that formula. It works every single time. So you can tell the vast difference, right? There's way more interest earned here, but it took us longer to get there, right? So we want the rate of return for both. How did I manage to do that? Oh well. So I'm going to go just under this. Rate of return is just the interest earned over what you started with, remember? The amount you put in times 100. And that actually turns out to be 50%. The rate of return for this one is a little bit more complicated. It's 989.28. It's still the interest. Remember, I used to make this future value minus present value, right? What the difference between what you started and you ended, but it's also the interest. Over, what are we going to put down in the denominator? You put down 10 grand, right? But you also put on more money, right? Like you made payments. How many payments did you make? You made 80.2144 payments of this. So not quite just 80, a bit more, right? So this number goes in here as well because that's your money that you put in there. All of that times 100. And I will use a highlighter here to make sure you understand where that number comes from, right? This one I put there as well. So in a sense, this is the money you've put in, and this is how much you've earned. Right? Rate of return is 989.28 over, this is just 14,010.72 times 100. You get 7.06% on that one. So it does make sense. You earned a lot more here as opposed to here. How much was invested in each scenario? What do we call this? Okay. In A, right? Let's call it first. We call this principal. Okay. The amount you put in is what we call the principal. Is like that. The amount you put in, and everything above that is the interest you earned. Okay. So in A, we put in 10,000. In B, we put in 10,000. That's not going to work out here because let me just go a little bit, and I'm just going to do it like this. In B, it's 10,000 plus 80.2144 payments of 50 bucks. So it's 10,000 plus 4,010 and 72. So in each scenario, you put in, right, 10 grand in the first one, and because there are some payments that were made, you put 14,000 of your own money. So you, right, like you made that happen. Okay. So I'm gonna stop here for a bit and ask you to go to page 40. Okay. So we're gonna pause. I'm gonna do more examples in a bit, and you've labeled your page numbers by now, hopefully. So go to page 40, and I want you to work on 40 and 41, those two pages, right? And the title kind of gives it away that there will be regular deposits here. I find that just dealing with examples with no deposit is a bit too easy. Like, I don't want to spend too much time on that, even though it can happen. Can I just make one correction here as I was working through this? Where was this again? Yeah. Example 2 on page 40, this one right here. And you need to change what was Adam's future value. And then B is what principal amount did Blake invest 5 years ago? Who earned more interest? Why? Okay? Right? Like, everything else stays the same. So play around with the TVM solver. Try to see if you can figure out how to answer things. Kind of like dip your feet in the water and just start something. Like, start to go somewhere. Maybe you'll be surprised how much you actually already know, right? Watch your signs. Watch for the little things, right? And highlight away, okay? And I will come around and give you a hand if you need to. I think I'm just going to show you because the time is flying today. It's a little messy, sorry. This is my draft version, right? But you should have recognized that if you make payments at the end of each 6-month period, that's twice a year, right? So your PY is 2. Your compounding periods are semi-annually, which also translates to 2. They happen to be the same. There are $500 payments made to the bank, so you put a negative. Interest rate is given. 5 years, right? 5 times PY is 10. You do not start with an amount, right? So it's 0. It's just talking about payments. So you end up with 5,449. You have a choice. You want to use interest 1 to 10 to figure out the interest, or use that formula that I gave you. Obviously, there are no payments, so this chunk here turns into 0. So you just end up subtracting. Oh no, there are payments. Sorry, never mind. The future value minus, there's no present value, right? There's no present value, but you make 10 payments of $500, so that's 5,000. So you still end up with 449.90, regardless of how you do it. Just ignore this part for now. That's just the principal, which is 5,000. We all know that we made 10 payments of 500, right, over the 5 years. Then Adam and Blake. I haven't quite finished this, but I hope this makes sense for Adam, right? So we're comparing Adam making payments and not making payments, right? How is that different? So Adam just makes $200 payments at the end of each year, which means there's 1 per year. It's compounded annually, which is 1, so they happen to be the same again. Quite often that will be the case. I start with 0, 5% interest rate, 5 years, so 5 times PY is still 5. I will figure out Adam's future value. Just change that to 1. Alpha, so that's 1,000. Just make sure your answer has, you can answer it just like that, but make sure it has the units associated with it. You do not need to have a negative sign or a positive for your answer. it just has to have that dollar sign. So if you're figuring out the interest rate, make sure it has a percent symbol next to it. So that's what Adam ends up with. And we're told that Blake also ends up with the same amount. So I can actually, sorry, that should not have a dot. I can just transfer this number over and do the same thing for Blake. But for Blake, I'll figure out how much he would have to start with to end up with the same amount. So it's 1105.13. No payments being made. There's just an initial deposit, same interest rate. It's still the same time. 5 times 1 is 5, right? How did it come up with PYCY? There are no payments, so I just focus on the compounding periods, which is 1. And then I match it, right? That's how I come up with the 1 and 1. Because some of you might look at this and be like, well, is there a payment? Because you're saying 1. This is just the way TDM solver works. It needs something here. So it's just saying the only payments that are being made is the interest that you're getting paid, right? So let's figure out the present value. So I can actually get rid of the payment and just go to present value. Alpha. So it's negative 865. Does it make sense for it to be negative? Yes, it does, because you're depositing that. So that shouldn't throw you off. And that's 90, right? So Blake, to get that same final amount, would need to deposit this much and just let it sit there. Okay. Who earned more interest and why? So we're going to do that here. For Adam, you could use, if you use the sum of interest, you're in trouble. Like if you have done all of this, because if you use sum of interest, you're only solving for Blake, not for Adam, right? So you got to watch out. I'm going to use the formula maybe. So it's future value minus present value minus n times payment. And there are various ways of doing this. So as long as you're consistent, you're okay. There's no present value. There are 5 payments of $200, which is 1,000, right? That's just 1,000. So this is actually not too bad. So it's 105.13 for Adam. Okay, and then Blake, you can use the same formula, or you can use sum of interest, but you can just go future value minus present value minus n times payment, and this just turns to 0 because there are no payments. So it's essentially just subtracting. Remember the compound interest formula? This is A, this is P, right? You're subtracting A minus P. There's 239.23, right, for Blake. So Blake earned more. Since he started off, right? Since he had a greater PV sounds greater principal to start. Okay, and I will tell you this: if you're young, right? If you're young, you're starting to get a paycheck. If you put in money into a savings account until you reach a point where it's like, you know what, I have so many other responsibilities now, I can't, and you just let it sit there, you're gonna earn quite a bit. Whereas if you wait, right? If you wait until you're older and then start making payments, you don't have the time to earn interest. You're trying to catch up, and I'm going to have an example where you compare that. What's better, starting at 20, putting in and stopping at 40, letting it sit there, or wait till you're 40 and just put in more every month to try to get to that same final amount. And you'll find out that starting to put money earlier and letting it sit there after a while is better than the other way around. It's better than playing catch up, right? Because in this case, we both want that same final goal, right? But you earn more interest this way. Your homework, I will say this. So if you go to page 44, you need to practice. That's very important. So page 44 to 48. Page 44 to 48. Some of them have deposits, some of them do not have deposits. And I will post the answer key, and just make sure you take some time to work through these, okay? And example 3 and 4 that we didn't go over, if you want to do that as well, I will post the answer key to that also, okay? So make sure you do that. You want a solid start so that